Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nazarul Mirzam bin Amiruddin. My project title is Design the Boost Converter to Step Up 12 VDC. For introduction, in this project, the circuit of boost converter has been designed to step up 5 VDC to 12 VDC. What does it mean by boost converter? Boost converter is a DC to DC power converter that steps up voltage from its input to its output. Next, it is a class switch mode power supply containing at least 2 semiconductor and 1 energy storage element. The software used to complete the simulation of the project is PSIM. PSIM stands for Physical Security Information Management. It developed by PowerSIM. PSIM help to complete the circuit, run the circuit and analyzing the circuit. Next, problem statement. Nowadays, the boost converter is widely developed as the use of it significantly important in electrical circuit. The available boost converter in the market has a very low efficiency. When it is less in efficiency, it will slow down the boost converter functionality. Second, boost converter is high in price, which make it less affordable as an electrical component. Next, for the objective, there are 2 objectives of the project. First, to design a DC-DC controller that steps up DC voltage and keep it constant when the input voltage or the load resistance are not necessarily constant. And the second one, to analyze the efficiency of the boost converter. Moving on to the project scope, this project focuses on design of boost converter to step up 12 VDC. Literature research about the efficiency of boost converter. I did research on the efficiency of the boost converter through journal article and several websites to get more information about boost converter. Not only the efficiency, I did the research together with the type, application and the advantages. Planning and selection of the circuit design. I designed few circuits to meet the exact circuit that required for this project. The design will be done in PSIM software. To design the circuit, PSIM software was used to run the simulation. There's some error that happened during the process, but I managed to identify and solve the problem. Using PSIM software to simulate the circuit, testing and commissioning the circuit, analyzing the boost converter performance. After running the circuit, the analyzing was done after getting the simulation to see the speed of the boost converter. Okay, this is the figure of the circuit and the simulation. The step on how I get the simulation result will be shown in the demo video after this. Next, we move to the application. First, automotive applications. Second, power amplifier application. Third, adaptive control application. Fourth, battery power system. And fifth, consumer electronics. Alright, so next for future recommendation. Future research should be devoted to the design and development of boost converter. There are few recommendations that I convinced can be improved on the boost converter in the future. The first one is to apply robust control technique in order to stabilize the converter. Moreover, optimizing the inductor value that will reduce both resistance and inductance. Besides, using the PSIM software itself, I would recommend to design the circuit on the printed circuit board layout. Alright, for the last one is conclusion. In conclusion, the objective of this project have successfully accomplished all objective purpose. The simulation has been successfully done using the PSIM software. This project able to step up DC voltage and keep it constant when the input voltage or the load resistance are not necessarily constant. The outcome of the project equivalent to the purpose of the project, and the main conclusion that can be drawn is that the boost converter step up to 12 VDC is successfully designed. That's all from me. Thank you. Here is my project demonstration. This is the circuit that I had designed in my project. The component that I use are inductor, diode, capacitor, resistance, MOSFET switch, on-off switch controller, square wave voltage source, and DC voltage source. I have placed the value of inductance that is equal 120 microhenry. For this capacitor is equal to 48 microfarad. The resistance is set to the same value, which is 10 ohm. However, I will change the duty ratio here to I will convert it to 0.6, and the frequency are 12k. And the last one, set the input voltage to 5 volt. Next, I will run the simulation, and the first thing I want to measure is V in and V out. Alright, this is the simulation for V in and V out. As you can see here, the V in is 5 volt and the V out, it is constant at 12 volt. Next, I want to show the inductor current and inductor voltage. Alright, this is the inductor voltage and inductor current. Based on this particular thing, we can always find out what is the peak current flowing through the device, so that we can measure peak current flowing through the inductor. We can actually design and we can select the devices that we want to use. The second thing here is that the current is well above the zero. So it is again in a continuous conduction mode. If I move back to this particular 0 point, we can see that this rising and flowing slope depends entirely on the equation that we developed for the inductor current and the inductor voltage. So this waveform can only be witnessed visually by either using the experimentation. In the simulation part, without undergoing that thing, we can visualize what is going on with inductor current and inductor voltage. Another thing important here, is, as we have learned, that the inductor voltage can instantaneously switch down. However, current requires a finite time, and inductor do not allow certain change in the current. Another point here is, if I may remove this one, I want to show you is the inductor and what is the capacitor current here. So, alright. So we can see again here that the capacitor current is actually a bidirectional current. So you can see at some time the capacitor is supplying the current, and sometimes sorry. Alright, so you can see at some time the capacitor is supplying the current, and sometimes the capacitor charge itself to some for the remaining period of time, and that it supplies to the load.
Alright, that's all from me. Thank you.